All right, good morning, Math Lab students. The first thing I want you to do is open up your presentation. You're actually going to follow along with class today using this presentation that you should already have open. And if you don't have it open, you can find it on Google Classroom under the tab for classwork. Okay, so the first thing we're going to do is review the launch. So we're in the second part of today's agenda. And what I would like you to do is take out the launch. The launch looks like this. And we're going to go ahead and practice evaluating the following functions. So let's do the first one together, and then we'll do the last one. So the first thing I'm going to do to evaluate a function is just copy down. So it looks like the function I'm using just looks like g of x equals 2x plus 5. And then something that's helpful for me is just thinking about, okay, whatever is in the parentheses is my x value, and there's my x in my equation. So then when I try to evaluate g of 2, I can clearly see that the x is being replaced by the 2. Therefore, I need to also plug in a 2 here. So wherever there's an x, I'm going to plug in or replace that x with a 2. 2 times 2 plus 5. And then from here, it's just a question of using PEMDAS to evaluate. So multiplication first. 2 times 2 is 4. And then 4 plus 5 would give me 9 as my final answer. And then I'm always going to remember to box my final answer. So key idea, whatever is inside the parentheses is going to get plugged in for x into your equation. Let's do the last one because it involves a negative number. When g of negative 2. Okay, so same thing. I'm going to first copy down my function. I'm still using the same one, g of x equals 2x plus 5. Okay, now the thing that I'm plugging in for x is my negative 2. G of negative 2 equals 2. Now I'm going to replace my x with negative 2 plus 5. Multiply 2 times negative 2 would be negative 4 plus 5. And negative 4 plus 5 is going to give me positive 1 as my final answer. Okay, so if seeing that example was helpful to help you complete the rest of the launch, I'm going to ask you to go ahead and evaluate g of 0 and g of 4 on your own. And then I want to skip ahead to this page. Let's quickly do 2 examples from this page together. So first thing I'm going to do, copy down the function, f of x equals x squared plus 3. The negative 2 is going in for the x. So then I'm going to do f of negative 2, replace the x with negative 2 squared plus 3. Following PEMDAS, exponents come before addition. Negative 2 squared, a negative times a negative is a positive. So negative 2 squared is positive 4 plus positive 3 would give me positive 7. So even when you have an exponent in there, you can still evaluate the same way, just using an exponent. Okay, this last one, we went over this a little bit, I think 2 weeks ago, but let's do it again. So it says, this one's a little different. It says find x when f of x equals 28. So the whole equation, the whole f of x is going to be equal to 28. First thing I'm going to do is just copy down my equation. F of x equals x squared plus 3. Now, instead of plugging in for x, I'm going to plug in for f of x. So meaning this whole equation, this whole f of x is going to be replaced with 28. So the 28 is actually going to get plugged into the left side of the equation. So we end up with 28 equals x squared plus 3. And then I'm going to go ahead and solve algebraically. So plus 3, I'm going to subtract 3 on both sides. that cancels out. 28 minus 3 is 25 equals x squared. And then I could think, okay, what number could I plug in for x? Squared would give me 25. To do that algebraically, I'd be like, okay, if I take the square root of x, then I also have to square root the other side. And good morning. And I end up with x equal to 5 as my positive answer. Technically, don't worry about this too much yet. Technically, my answer would be positive or negative 5 because in order to get 25, I could have done negative 5 squared. That would have given me positive 25. And then also positive 5 squared would give me positive 25. So therefore, my answer is going to be either positive or negative 5 would give me 25. Okay, moving on. I'm going to have you open up your slides. And on your slide, we're going to take some very quick notes. Before you do that, make sure you finish up the launch. So I'm going to have you, if you haven't already, go back and do all the other problems on the launch. Once you're done with that, so you can pause the video and do that. Once you played the video again, I'm going to have you open up this note slide and we're going to go through some quick notes. Okay, so here in your slide, we have some kind of key terms. The first term you'll need to know for Unit 2 is this word polynomial. We're going to be talking about this for a very long time. And basically that just means this kind of crazy looking expression that has multiple terms. It has multiple x's. There's things that are cubed. There's things that are squared. Basically just a math sentence, a math equation with lots of different terms. So let's add, I'm using this word term, so let's actually add that to this diagram. I would like you to insert a circle here, and you can make it transparent. I'm going to make mine colored so I can see it. And let's go ahead and label that. So get an arrow. And I'm going to have you label it as a term. So you have your arrow, insert a text box, and the vocabulary word for this is a term. So this kind of, the coefficient, the variable, the exponent all together, we would call that a term. So we'd say this expression has 3 terms. Let's just write that down. Or we'll say this polynomial has 3 terms. Okay, so typing that into your note slide. Then the next kind of piece we're going to add, you already have this 4 is labeled. We call that the leading coefficient. It's that number that's multiplied by this exponent to the highest power. We have the degree. The degree is the highest exponent in the whole polynomial. So we have a 3, a 2, and a 1, or no exponent. And we'd say the degree of the polynomial is 3 because the power of the highest exponent in the whole polynomial is 3. Okay, the one more thing I would like you to add, let's add one more text box. And let's add one more piece to this equation. Let's say we had a plus 5 at the end. So no x, just a normal number. And let's make it big so it looks like it's part of the equation. Okay. So say we had the same expression, the same polynomial, but we just had a plus 5 at the end. The one other word you'll need to know is that this constant, this number is known as a constant. So go ahead and label that last term, the one that does not have an x. We're going to call that the constant. It has no x next to it. Okay, I'm going to wrap up this video here. I want you to pause the video and go ahead and try this classifying